Welcome back to Maths and Stats Tutor UK. In this video, we're going to look at expanding triple brackets. In the previous two videos, we looked at expanding single and double brackets. So how can we apply that to here? We know that expanding brackets means we need to use an appropriate algebraic or numerical method to remove brackets. Simplification means to collect like terms. But how do we expand triple brackets? Since there's no concrete method for expanding three brackets all together, we are going to have to expand two of the brackets first. Does it matter which two brackets we expand? No, it does not, because multiplication is commutative. This means that the order of multiplication does not matter. And so it doesn't matter which two brackets we expand first. I'm going to start off by expanding the final two brackets first. But you can expand the first and the last bracket, as that might be a bit more simpler. So to expand x plus 4 times x plus 1, we do x times x plus x times 1 plus 4 times x plus 4 times 1. Now, if you're unsure how to do this, please go back and watch clip 2, the previous video. This should simplify to x squared plus x plus 4x plus 4, which simplifies to x squared plus 5x plus 4. At this stage, although we've got three terms in our second bracket, we're going to multiply each of the two terms in the first bracket to that, in the same way as expanding double brackets with two terms in each bracket. So we're going to do x times x squared plus 5x plus 4, and then do a 2 times x squared plus 5x plus 4. Expanding each of these out as single brackets, we've got x cubed plus 5x squared plus 4x plus 2x squared plus 10x plus 8. Do we have like terms? Yes, we do. We've got 5x squared and 2x squared. And we also have 4x and 10x. Combining these pairs of like terms simplifies everything to x cubed plus 7x squared plus 14x plus 8. Here we have a cubic expression, or better known as a polynomial, since we've got multiple terms. Let's have a look at example number 2. We've got x minus 3 times x plus 5 times x minus 2. We can expand brackets in any order, but I'm going to stick to expanding the last two first. So we've got an x plus 5 times x plus 2 as the final bracket. What does that become if we expand that? Well, that will become x squared minus 2x plus 5x minus 10, which simplifies to x squared plus 3x minus 10. So I now need to expand this double bracket. What should I do next? I need to multiply x, the first term in the first bracket, to all of the terms in the second bracket. And I do the same with the minus 3. But be careful that we need to take into account the signs. So we've got x lots of x squared plus 3x minus 10 minus 3 lots of x squared plus 3x minus 10. And if we expand the brackets, what do we have? We have x cubed plus 3x squared minus 10x from the first bracket expanded. From the second part, we have the following. We need to take into account the signs, so we would have minus 3x squared minus 9x plus 30. Do we have like terms? Yes, we do. We've got a plus 3x squared and a minus 3x squared. And we also have a minus 10x and a minus 9x. 3x squared minus 3x squared cancels, so we're left with only x cubed minus 10x minus 9x. That will simplify to minus 19x plus 30. So we do not have an x squared term because it has cancelled out. Let's have a look at this final example. We have x plus 3, lots of x minus 1 brackets squared. What's unusual about this example? Well, we have an x minus 1 bracket squared. So how else can I write this? We can write it as x plus 3, lots of x minus 1 times x minus 1. Because this bracket is what we call a complete square or a completed square. So that means it's just telling us that it's x minus 1 times itself. To expand completed square, what can we do? Well, we can use what we've just used here, a method similar to the FOIL method, but we can take a shortcut because we know a minus b squared is equivalent to a squared minus 2ab plus b squared. So I can expand this completed square much more easily using this formula. So that will become x plus 3 lots of, well, x squared minus 2ab is minus 2 times x times the 1, so minus 2x, b squared is 1 squared, so plus 1. So that simplifies to x squared minus 2x plus 1. So what do I do next? I need to multiply x to each of the terms in my third bracket, and I do the same with 3. So I've got x lots of x squared minus 2x plus 1 plus 3 lots of x squared minus 2x plus 1. And if we expand the brackets, we've got x cubed minus 2x squared plus x plus 3x squared minus 6x plus 3. Do we have like terms? Of course we do. Minus 2x squared and 3x squared. And then we have our other like term, the x and the minus 6x. We will have x cubed starting off. Then we have minus 2x squared plus 3x squared. That's the same as 3x squared minus 2x squared, which is plus x squared. That's due to the commutativity of addition. X minus 6x is minus 5x, and then we've got a plus 3. Usually we would end up with a maximum of 4 terms for expanding triple brackets, where each of the brackets contains just x's as the term with the highest power. But that can differ if we have multiple terms in each bracket. Here are some problems for you to try. Pause the video and have a go. Okay, I hope you've had a go at these problems. Let's go through them. I've got a 2x plus 1 times x plus 2 times x plus 3. So it's easier to expand the last two brackets, the x plus 2 times x plus 3. You should have got for that one x squared plus 5x plus 6, expanding the last bracket. Then we're going to multiply each of the two terms in the first bracket to all of the terms in the second bracket. So you would have 2x times x squared plus 5x plus 6, followed by a plus 1 lot of x squared plus 5x plus 6. But we don't need the 1, so I'm just going to put brackets around the term. Now expanding that gives you 2x cubed plus 10x squared plus 12x plus x squared plus 5x plus 6. What about like terms? Well, we've got 10x squared and x squared, and then we've got 12x and plus 5x. So that hopefully means that you should have got 2x cubed plus 11x squared plus 17x plus 6 in descending powers of x. Question 2. Now this is a special one, because if you'd have expanded the last two terms, you would notice that is of the form a plus b times a minus b. So that would have given you what we call a difference of two squares. So we would end up with two terms in the second bracket, and that's x squared minus 9, since it's x plus 3 times x minus 3. And we would expand this similarly to expanding simple two bracket expressions. So that would be 3x lot of x squared minus 9 minus 1 lot of x squared minus 9. But we would write that as minus bracket x squared minus 9, since negative 1 and 1 are not written outside the brackets. So simplifying that gives us 3x cubed minus 27x for the first bracket, and then minus x squared plus 9 for the second bracket expanded. Do we have like terms? No, we don't. So we leave it as it is. Or you can simply write this in descending orders of x, and that becomes 3x cubed minus x squared minus 27x plus 9. Last question here. In all of the examples, we looked at expanding just this last two brackets. But in this case, it's ideal to expand the completed square, since that is of the form 2x minus 3 times 2x minus 3. How did we expand completed squares? Well, we used the fact that a minus b squared is a squared minus 2ab plus b squared. So we can do the same here. We can expand the first two brackets, and that will leave us with the 4x squared. Minus 2ab, it will be minus 2 times 2x times 3. So that means it's going to be minus 2 lots of 6x, so minus 12x. And then b squared is the minus 3 squared, which is going to be a plus 9. And we multiply that to 4 minus x. Since there's less terms, or the least number of terms in the second bracket, it's ideal to multiply everything in the second bracket to the first bracket. Recall that because multiplication is commutative, like addition, we can do multiplication in any order. So you can multiply everything from the second bracket to the first bracket if needed for simplicity. So we're going to do 4 times all of the terms in the first bracket. Then we're going to do x times all of the terms in the first bracket. So that's going to give us 4 lots of 4x squared minus 12x plus 9. But be careful, we don't just have an x, we have a minus x. So we're going to do minus x lots of 4x squared minus 12x plus 9. If we expand the first bracket, what do we get? We get 16x squared minus 48x plus 36. What about for the second single bracket? that becomes minus 4x cubed plus 12x squared minus 9x. Do we have any like terms? Yes, we do. 16x squared and plus 12x squared, like term. And minus 48x and minus 9x are like terms. Because the x cubed term is a negative, it's better to write this final simplified expression in ascending orders of x, or ascending powers of x, which means we go up in powers. So we're going to start off with the 36, then we're going to have the x term. To get the x term, we're going to do minus 48x minus 9x, which is minus 57x. Then we're going to do 16x squared plus 12x squared, so plus 28x squared. Then we end off with the 4x cubed at the end. So we have 36 minus 57x plus 28x squared minus 4x cubed. That will be it for this video. Don't forget to subscribe to Maths and Stats Tutor UK, like the video and give it a thumbs up. And don't forget to turn on the notification by hitting the bell so that you are informed and notified of future videos that will be uploaded to this channel. And don't forget to follow my social media. Link for that will be in the comments and the descriptions. Feel free to comment on these videos and give suggestions on what I can improve and what I should do next. See you in the next video.